Welcome to this Unacademy CAT4MBA channel. My name is Ronak Shah, and as you know, this is 9 p.m. daily live show. So we have started with permutation and combination. So in this session, we are going to continue with the same topic. In fact, this is the second session of permutation and combination. So I'm going to help you out to understand all the concepts related to permutation and combination completely. So once again, in case if you are new to this channel, let me quickly tell you something about myself. So I am an MBA and I have also done my engineering. I have more than 12 years of training experience and I've trained plenty of students for CAT and other MBA entrance exams, and I personally appeared for CAT many times. In fact, we have the best of the educators on this platform, so you can attend our daily live sessions throughout the day. Right, so this is the agenda for today's session. This session particularly, we are going to discuss permutation. Before that, we'll quickly revise the counting principle. In case if you had missed the first session, then you can understand that part, and then we'll go ahead with permutation. So as you know, permutation means arrangement. So arrangements can be of different types, like linear arrangement or circular arrangement, and so on and so forth. We'll also look at some special cases. Then we'll discuss a bit about combination, and we'll also practice plenty of questions. Right, so I hope all of you are geared up. Let me see who all are there quickly. Hi Varshini, Shubhankar, Nicole, Ravi, Sudarshana. Good evening to all of you. Yes, so let's go ahead and just to quickly tell you about our channel. So on Unacademy CAT4MBA YouTube channel, we conduct daily live sessions, and we also have our Telegram channel. So in case if you haven't subscribed to our channel, you can quickly do it so that you can get regular updates in the coming days. And yes, we also have subscription plans, so you can attend the sessions over here on YouTube, and you can also attend on Unacademy platform, and you can go for the subscription plan so that you can attend my courses and courses from other educators, and you can also access to test series, leaderboard, and you can get personal attention. So these are various plans. You can go for 6 months plan or 12 months plan. In fact, if you're planning to target CAT next year, then you can go for this 24 months plan as well, and they're very cost effective. Do not forget to use my referral code, which is SHAH10. So using that, you will get some discount as well. Right, so as you know that our objective is to crack CAT exam. So let's go ahead in that direction. So everyone, once again, hi Robin. So in the last session, we had discussed this counting principle. So this is that principle. We clearly understood that whenever we want to perfect two tasks together, whenever we want to perform two tasks together, we multiply the number of ways of performing those tasks. And wherever we use word either or, either this or that, then we'll add the number of ways of performing those tasks. Right, so AND means multiplication and OR means addition. So this is what you need to understand. And few important points that I had discussed, I had mentioned in the previous session. So I'm sure all of you remember that. Quickly going ahead with the concept of permutation and combination. So what is the difference between these two? Many students get confused between this one case of where to use permutation, where to use combination. So this is what I'm going to make pretty clear in next 10 minutes. Okay, so permutation means arrangement. So where order of object is important, you will apply concept of permutation. So an example of that is a 3-digit number is nothing but arrangement of digits, because if I take this 3 digits 1, 2 and 3, then I can make different numbers using the same digits depending upon the order in which I'm putting them, right? So 1, 2, 3 is different from 2, 3, 1 and so on and so forth. So this is permutation. In fact, when you sit on chairs in a line, again that's nothing but an example of permutation, or you can say arrangement where order matters. So what is combination? So combination means grouping or selection where order doesn't matter, right? So when you select a team of 4 players, so that for a team of 4 players is nothing but combination A, B, C, D. So here order doesn't matter, but when the same 4 players are sitting on a chair like this A, B, C, D, or on a bench, then A, B, C, D is different from B, A, C, D arrangement. So this is an arrangement, while this is a combination, right? So I'm sure you have understood what is the key difference between these two. Okay, so let's go ahead and let's take up some conceptual question. Now you need to quickly tell me what concept will be used over here, whether we are going to use permutation or combination in each of the following situation. So what you need to do is you will read that statement and then you will type your answer. For example, for this A, situation A, pizza toppings, is it permutation or combination? Is order important over there? If yes, then you will type P. If not, then you will type C. Means it's combination. So what is that? Can you tell me? Is it permutation or combination? It's combination. So this is how I expect you to enter the answer. For situation A, it's C, right? What about B? Assigning seats to the students on the first day of the school. Is it permutation or combination? For B, what answer will you enter? P or C? Enter your answer over there in the chat box. Correct, it's permutation, everyone, because it's arrangement, sitting arrangement, right? Same way, what can you say about C? Picking actors for lead role and supporting role. Is it permutation or combination? So lead role and supporting role, so it's going to be permutation. Correct? Okay, because see here, if you take A for lead role and B for supporting role, instead if you take B for lead role and A for supporting role, it will be different, right? And that's why order matters. So it will be a case of permutation. What about D? Number lock, permutation or combination? Yes guys, keep typing your answer in the chat box. So D will be permutation, because number lock, as you understand, order matters. 1, 2, 3. If that's the code, then 3, 2, 1 will not be applicable. Making committee. So committee is nothing but combination. It's a group of people, right? So committee of ABC, same as committee of CAB. Then handshakes, again it's combination. Yes, do you all agree with this, everyone? Right. G, drawing 2 cards simultaneously from a deck of cards. So if I draw 2 cards, it will become combination of 2 cards, because whether it's king or queen or king, doesn't matter, we are picking them together. So it's a combination of 2 cards. But drawing 2 cards one after another, now order matters. First getting king card and then queen card, and vice versa is different, right? So order matters. So H will be permutation, right? What about this one? I, scheduling appointments. Scheduling appointments. So 9 o'clock, Mr. A, 10 o'clock, Mr. B, 11 o'clock, Mr. C. Can I say it's an order? Instead of A, if I fix appointment with C and then over here with A, this will be different, right? So this scheduling appointment is permutation. Correct. All of you are pretty clear with this now, I'm sure. What about J, making a pulse set? So all pulse are of different color. So it's nothing but it's a circular arrangement, circular permutation. So you can make different sets depending upon what order of pulse, what color of pulse have you kept, right? So that's why it's nothing but permutation. It's a circular permutation. Right. So have you all understood this? Show me a thumbs up quickly if you all have understood. Right. In fact, this part was covered. Correct. I got that. So that's why I was speaking out for you that part. So I'm sure all of you have understood. Right. Let's go ahead quickly. So let's understand this one through a different example. So now we are talking about permutation and then we'll discuss combination. So please pay attention for 2 minutes. In how many different ways can 5 persons sit on 3 chairs arranged in a line? Right now guys, please understand one thing. The chairs, whether they are same or different, when you put 3 chairs like this, all chairs will be different. This will be called leftmost chair, this will be called rightmost chair, and this is the middle chair, right? Okay, fine. So that's why even if all of them are of same colors, same brand, same size, but still based on the positions, they are different, right? So what are the total number of ways? So let me just show you 5 people, A, B, C, D, E. So on the first chair, any one of 5 person can sit, and then on the second chair, remaining 4, anyone from remaining 4 can sit, and on the third chair, from remaining 3, anyone can sit. So this is nothing but 5P3. So this is how that concept of NPR was derived, that when you want to arrange n different objects on r distinct positions, it can be done in NPR ways. For example, if you want to arrange 5 people on 3 chairs, it can be done in 5P3 ways. Now what is the formula for NPR? So it's n factorial upon n minus r factorial. But as I mentioned, as I always mention that we will try to avoid using formula up to the extent possible. So let's quickly understand a shortcut that how to quickly calculate 5P3. So 5P3 means this is how you will think. You need to write 5 3 steps backward. 5P3 means write down 5 3 steps backward. That is 5 into 4 into 3. That's it. This is nothing but 5p3. So that we can make out here. So for example, if I ask you what is 10p2, so 10p2 is nothing but writing 10 2 steps backward, that is 10 into 9, or 8p4, so writing 8 4 steps backward, so 8 7 6 and 5. So this will be 8p4. So I'm sure all of you have understood this part. Yeah, hi Sumit, hi Akash. Right, great to see all of you. Fine. So guys, the points that I just explained, it's mentioned over here. In general, R objects can be arranged out of n distinct objects in NPR ways, right? Means you want to arrange R objects on R positions out of these n objects. So arranging 5 people on 3 chairs kaho, या फिर arranging 3 out of 5 people on 3 chairs kaho. Both of these are same. Please understand. Arranging 5 people on 3 chairs is also 5p3, or arranging 3 out of 5 people on 3 chairs. So it's again 5p3. Of course, only 3 people are going to sit on chairs, right? No one is going to sit on the laps of others, right? Okay, fine. So guys, the formula is also given over here. In some calculations, we may require this formula. So just remember that for timing. Yeah, now some important points related to this. Guys, NPN is n factorial. NPN is n factorial. For example, if there are 5 people and you want to arrange on 5 chairs, so straight away you will say it will be 5 factorial by 5 into 4 into 3 into 2 into 1. So this is why it's 5 factorial. Or if I ask you this question, how many different words can be made using the letters of the word bridge, BRIDGE? So how many words can be made using the letters of the word bridge? Means we need to create different words by shuffling these letters. So there are 6 letters. 6 letters can be shuffled in 6 factorial ways, or 6 letters can be rearranged, or 6 letters can be arranged in 6 factorial ways. So I hope all of you are pretty clear now. Yes, everyone. So let's look at this one more important point. So this one. If there are n objects of which p1 are alike and of one kind, p2 are alike and of another kind, p3 are alike and of third kind, and so on and so forth, the number of permutations or number of arrangements of these n objects will be n factorial divided by p1 factorial, p2 factorial, p3 factorial, and so on and so forth. See, please understand, when I asked you how many different words can be made using the letters of the word bridge, you straight away told me, sir, it's 6 factorial, because all the letters were distinct, all the objects to be arranged were distinct, right? But when some of them are identical, then we'll have to take care of that. In fact, we can apply this formula. So let's quickly look at one scenario. How many words can be made using the letters of the word apple? So how many letters are there in this word apple? Of course, there are 5 letters. So it would have been 5 factorial had all the letters been different. But here there are 2 p's. So we will have to divide by 2 factorial. Are we clear with this point? Show me a thumbs up if you all have understood this. Everyone? Yeah. Okay. Great. So let's go ahead and let's understand circular permutation. So we are talking about circular permutation, right? Circular arrangement. So let's quickly understand this. So number of ways to arrange n objects in a circle is equal to n minus 1 factorial. That means if I want to arrange 5 people, A, B, C, D, E, in a circle on 5 chairs, there are 4 factorial ways, not 5 factorial ways. Of course, there are 5 chairs, but still there are 4 factorial ways. Robin, your question is if one can reuse the letter, then please understand, guys, remember this point, that when I give you this kind of question, how many words can be made using the letters of the word bridge, that means we need to use only those letters. Or using the letters of the word apple, that means we need to shuffle only those letters of that word. Okay, so if there is only one A in apple, you need to use just one A in the words that you are creating. If there are 2 P's in the apple, you just need to use that, because we are using that word using the letters of the word apple. Are you getting this point? So it's everything about this word using the letters of that word. So I hope you understand. You know, the letters means you understand article the, right? It's a definite article. It refers to those specific objects. Correct. Okay, fine. So guys, coming back to this one, we are talking about circular permutation. So number of ways to arrange n objects in a circle is n minus 1 factorial. For example, if I want to arrange this 5 people on 5 chairs in a circle, so there is 4 factorial ways. Now this is slightly surprising. Why there is 4 factorial ways? Why not 5? Because there are 5 positions. So like I arrange in a line, I can also put them in a circle. What's the problem? So the problem is when the 5 chairs are in a line, all the chairs are different. How are they different? So let's look at this one. This is called leftmost chair. This is called rightmost chair. This is called middle chair, and so on and so forth. This is second from the left. This is second from the right, and so on and so forth. But when the chairs are arranged in a circle, they are not different. They are same. So for example, in the linear arrangement, when A sits over here or A sits over here, these are 2 different ways of A sitting. Correct? Because in the first case, A will think I am sitting on the left chair. In the second scenario, A will say I am sitting on the rightmost chair, right? But in the case of so in the case of circular arrangement, that's not the case. So let's quickly understand that part. So here A is on the left chair, here A is on the right chair. But when A sits over here or any of this chair, ultimately these are one and same ways, right? So there is no reference actually, unless you put some air condition or some air cooler over here. So whosoever will be sitting over here, they'll get some cool breeze. So with reference to air cooler, of course, these chairs are different. But if nothing is available over there, so these positions are all same. So now let's understand. You know, when there is a linear arrangement, for first person, there are 5 ways. For second person, there are 4 ways. For third person, there are 3 ways, and so on and so forth. But in the circular arrangement, for first person, there is only one position. Though there are 5 chairs, but all 5 chairs are same. There is only one position, right? So the first person can sit in just one way. Now suppose we have asked A to sit over here. A जाके चुपचाप उधर बैठ गया. Okay. Now with reference to A, all these positions are different. So now for B, how many positions are there? 4 different positions are there. Why? Because if B sits over here, B will say that, okay, I'm sitting on or A is on my right hand side, because this is the right side of B. If B sits over here, so B will say, okay, A is on my left hand side. Okay, suppose A is a notorious person. So one is always cautious, who on my left or right, who is notorious. So it's A. So here A is sitting on the right hand side of B. Here A is sitting on the left hand side of B. And that's why once you have fixed the position of one person, all the other chairs are different. So this remaining 4 people can be arranged in 4 factorial ways. And that's why in general, n people can be arranged in n minus 1 factorial ways. Guys, are we all clear with this? Show me a thumbs up if you all have understood. नहीं दोस्तों, आपका ज्यादा नहीं छूटा है. So Rajat, Akash, what we discussed is permutation means arrangement. Let me quickly recap in case if you have just joined. So I mentioned this thing, permutation means arrangement and combination means grouping. So wherever order is important, you will use concept of permutation. If order is not important, you will use concept of combination, right? And then I gave some examples. So yes, I explained this formula. In fact, that will be covered in the upcoming questions. So we are going to take plenty of questions. So you will be able to understand that. Are we clear? Now relax and understand. So I'm explaining the circular permutation. So circular permutation, I'm sure you'll remember that. Now there is one more case of circular permutation. So this is what we need to understand. Another case of circular permutation. Okay, everyone. I don't know what's the problem with this one. Just a second. Right. Once again, my favorite red color. It's blue also, by the way. So if clockwise and counterclockwise arrangements are same, then the number of circular arrangements will be n minus 1 factorial by 2. Now let's understand the scenario. Suppose there are 5 people A, B, C, D, E. Okay, and we ask them to sit in a circle. So first they sat like this: A over here, B over here, C, then D and E. Instead, if we ask them to sit like this one: A, then B, then C, then D and E. Of course, these two are two different arrangements, because with reference to A, if you look at B is on this side, and with reference to A, B is over here. So these are two different arrangements when we want to arrange 5 people around a circle. Okay, but what if this 5 A, B, C, D are 5 different color pearls? So A is some color pearl, then B is another color pearl, C, D, E, these are different pearls. Okay, now if you make a pearl set like this one, A, B, C, D, E, and if you make another pearl set like this one, A, B, C, D, can I say both of these are one and same pearl sets? Because if I flip this pearl set upside down, the first pearl set, when we flip it upside down, it will result in the second pearl set that I've shown. So what I'm trying to tell you is clockwise and counterclockwise arrangements are same here, and that's why total number of arrangements, total number of circular permutation will become half. Because A, B, C, D, E and A, B, C, D, E will be one and same. So total number of arrangements will become half. And that's how you got this formula n minus 1 factorial by 2. Are we all clear with these two cases of circular permutation? Show me a thumbs up once you have understood this quickly. Everyone? Yeah. Great. Okay. And yes guys, do not forget to press the like button. So quickly like this video. Chalo jaldi se like button dabao. Let's have maximum likes over here. Right, great. And then start solving this question. So question number 1, 2 and 3. Third question, in how many ways can 5 people be arranged on 8 chairs? So just in case if you are not able to see that because of my head. Okay. Fine, but please try to answer this first question. In how many ways can 6 boys and 3 girls be arranged on 5 chairs? So we need to arrange total 9 people on 5 chairs. Can I say it's 9p5? Everyone? Yes? Okay. In how many ways 5 people out of 8 can be seated on 5 chairs? So of course it will be 8p5. 8 लोगों को 5 चेयर पे बिठाना है, 8p5. In how many ways 5 people can be arranged on 8 chairs? Now let's quickly understand this part. There are 5 people. And there are more chairs. There are 8 chairs. So in how many ways can it be done? Now see, please understand, here the chairs are more. So we'll not think that how many people can sit on first chair, then how many are left for second, and so on and so forth. We'll not do it this way. Instead, we'll think it this way. Okay, how many options does A have to go and sit? Can I say A has 5 options? Same way, sorry, A has 8 options. Same way, B has 7 options. C is left with now 6 options क्योंकि A and B ने 2 चेयर ले लिए, तो अब C के लिए कितने चेयर बचे? 6 चेयर. Then D has 5 options and E has 4 options. This is also nothing but 8p5. Are you all clear with this point? So 8 लोगों को 5 चेयर पे बिठाना है या 5 लोगों को 8 चेयर पे बिठाना है? The total number of ways will remain same, 8p5. Correct? So please keep this thing in your mind. अभी इसमें कोई गलती नहीं होनी चाहिए. Okay, we will require to use this thing in the subsequent question, and I'll ask you that. Okay, right guys, so tell me the answer for this one quickly. Tell me the answer for this question, not the actual answer. Tell me the answer in factorial form. So 6 factorial into 5 factorial into 4 factorial, something like that. So please type your answer in the chat box quickly. So there are 6 books on economics, 5 on history and 3 on biology to be arranged on a shelf, so that books on each subject are always together. And one more thing, books on the same subjects are different. So these 6 economic books are from 6 different authors, 5 history books are from 5 different authors, and same way these 3 biology books are also different. So here is that shelf. Now what I'll do is I'll consider the 6 books of economics as one economic book. I'll make a bunch and I'll consider as one bunch. So this is how I'll keep. It's a bunch of economic books. Same way, I have bunch of history books and I have bunch of biology books. So the first thing that I'll think is these 3 bunches can be arranged in a line in 3 factorial ways. Of course, 3 objects, there are 3 different objects, so it can be arranged in 3 factorial ways. Yeah. Okay, and now these books in the economics bunch can be arranged internally in 6 factorial ways, and this books can be arranged in 5 factorial ways, and same with this can be arranged in 3 factorial ways. Correct. So are you all clear with this point? Right. 6 factorial into 5 factorial into 3 factorial into 3 factorial. You can write it either way. So this is the answer. Right. So all of you got it right. Akash, it's not 14 factorial divided by 6 factorial. That's incorrect, because you need to keep these books always together. You need to keep these books always together. You need to keep these books always together. So first you will have to make bunches. You will arrange those bunches. It can be done in 3 factorial ways, and then internally those books can be arranged in this many factorial ways. So please correct yourself. Okay, so guys, tell me what will be the answer for this one. Akash, in this situation, you will use that concept. What calculation you have done can be applied over here for this question. Mathematics, quickly. So yeah, there are 11 letters, so 11 factorial, but then how many letters are identical? So there are 2 M's. There are 2 M's, so divide by 2 factorial. Then there are 2 A's, so divide by further 2 factorial. And there are 2 T's, T, so further divide by 2 factorial. Are you all clear with this, everyone? Right. So this was not that difficult, but yes, this question you need to be pretty careful. So how many words can be made using the letters of the word mathematics such that the vowels are always together? See, whatever objects you want to keep together, you just make them, club them and consider as one object. Whatever objects or people you want to keep together, just club them and consider as one group or one object. That's it. That's a method. So here, let me quickly write down what are the vowels and what are the consonants. So vowels are A, then E and I. These are the vowels. What are the consonant? So I have 2 M's, 2 T, and then H, C, S. So these are the consonant. So I'll consider this set of vowel as just one vowel, W. So now what I need to do is, my first task is, I need to arrange, don't look at these letters right now. Just look at this one W and this 7 letters. So total 8 letters. You need to arrange these 8 letters. So can I say 8 letters can be arranged in 8 factorial ways? But in this 8 letter, this 2M and 2 T's are there. So you'll have to divide by 2 factorial into 2 factorial. This is the first step. Okay, what we did is we clubbed the vowels and then we considered as one vowel W. So total now we have 8 letters to arrange, which can be arranged in 8 factorial, divide by 2 factorial into 2 factorial. And now whatever this vowel that we had clubbed, so this 4 vowels can internally be arranged in 4 factorial by 2 factorial ways, because there are 2 A's. So I have divided by 2 factorial also. So this is your answer. Are you all clear with this, everyone? So show me a thumbs up quickly. And yes, do not forget to press the like button in case if you haven't done this thing. जैसे मंदिर में जाते हैं पहले हम घंटा बजाते हैं ना, तो वैसे ही जब भी आप डेली लाइफ में आओ, पहले लाइक का बटन दबा दो ताकि कोई टेंशन ही ना रहे. Great. Okay, guys, good. Very obedient. Fine. Okay. So one more question for you guys. In how many ways can 4 people be seated on 4 chairs kept around a circular table? Of course, it will be 3 factorial. So this was a simple question. Let me give you a tricky question. So in how many ways can 4 people be seated on 5 chairs kept around a circular table? Now please understand, the number of chairs are more and people are less. Okay. So guys, whenever you come across such closed arrangement questions, whether it's a circular table or a square table or a rectangular table, all of these are circular closed arrangements. Always think about the first person. How many different options does the first person have? So here I'm just putting those 5 chairs quickly, right? And these are the 4 people, A, B, C, D, E. Yes, that's correct. Shubhankar, 24 is correct for this question. Okay. So now, how many different options does the first person have? Can I say first person has just one way? The first person can be placed in just one way. The first person has just one option, right? Now, suppose you fixed A over here. Now, all these 4 chairs are different. Okay. And there are 4 people, sorry. So there are only 4 people, by the way. So now this 3 people can be arranged on 4 chairs. Can I say in 4p3 ways? 4 people on 3 chairs or 3 people on 4 chairs? It's one and same. So 4p3 ways, because once you have fixed position of one person, all these chairs are different, all these positions are different. So we have 4 different positions now, and we have 3 people. So 3 people on 4 chairs, again 4p3, which is nothing but 24. So answer is option B. Yes, are you all clear? So let's look at some slightly difficult question. Now please try for this question. I'm giving you 30 seconds time to solve this question. And this is again a CAT question, guys. It's a CAT question. Similar question has been asked, only the values have been changed, right? Okay. So in how many ways can 8 people be arranged around a square table with 3 chairs on each side? So make it 2 chairs, by the way. It's 2 chairs on each side, right? In how many ways can this 8 people be arranged on this square table with 2 chairs on each side? This is typo. Yeah, it's option D. Many of you got it right. So guys, as I mentioned, again it's a closed arrangement, so think from the first person's perspective, that let's take this 8 people as A, B, C, D up to H. So how many different positions does A have? So now these 4 sides are definitely same. So on which side does A sit doesn't matter, right? But if we choose this side, suppose, so on this side A can sit on the left chair or on the right chair. So for a first person there are 2 different positions. Now suppose we fixed A on this chair. We have fixed A on this chair, and all these remaining 7 chairs are different with reference to A. So this 7 people can sit in 7 factorial ways. So answer is option D. Correct. So I'm sure you can tackle the similar question. Okay, so what will be the answer for this one? So once again, there are 10 people, A, B, C, D up to J. How many different positions does A have? So on which longer side A sits doesn't matter. Both of these are same way, both of these are same. So A can sit either on a longer side or on a shorter side. So how many different positions does A have? 5 different positions, right? So the first person can be placed in 5 different ways. And once you have fixed A over here, then all the 9 chairs are different. So remaining 9 people can be arranged in 9 factorial ways. So once again, option D. It's just a coincidence that for 2 questions, it was option D. Don't assume that there is a pattern here, right? So please try for this question honestly. In how many ways can 9 people be arranged around an equilateral triangle? Okay, around an equilateral triangle table with 3 chairs on each side. So once again, for first person 3 ways, remaining 8 people 8 factorial ways. Oh, this coincidence continues. Option D, right? Okay, great guys. So what about this one? In how many ways can 8 people be arranged around an isosceles triangle table with 3 chairs on each side? Okay, on each equal side, and 2 chairs on the third side. So what will be the answer for this question? Can you quickly type the answer in the chat box? Yeah. What will be the answer for this, guys? Quickly. Yep. How about the others? Ravi, then Sumit, are you all there? Akash, you look lost. Where are you all, guys? Sudarshana, yeah, she's there. Guys, the answer will be 8 factorial. The answer will be 8 factorial because all these chairs are different with reference to this unequal side. So with reference to this side, this chair, all these chairs are different. Okay, so all are different. So that's why it's 8 factorial. Very simple. Yep, great. Okay, so guys, time for the commercial break. you it's just of 10 seconds by the way. But yes, on a serious note guys, it's high time that you take up the test series, and if you go for that, do not forget to use my referral code. Go for the 6 months or 12 months plan, whatever you feel comfortable, and they're definitely cost effective compared to other academies. So yeah, you can go for that, because see, I'm also going to conduct mock test analysis in the coming days. So for that, you should have taken this mock test. You should have taken this particular mock test. So even if you have taken some other academy subscription, you can also go for this one simultaneously. You can go for smaller subscription if you want, and you can use my referral code and get the discount, and keep following me, right? If you're attending my session for the first time and if you want to attend more of my session, then you can attend this sessions. These are the timings on YouTube channel. So you can attend my sessions every day from 2 to 3 p.m, which is mainly on basics of quant, at least for this week. And from next week, I'm going to take LR sessions or some other topics in the afternoon, and evening 9 to 10 p.m. will always be about CAT quant, right? So this is how I conduct session. And on Unacademy app, so if you haven't downloaded the app, please do it, and quickly follow me by the name Ronak Kumar Shah, and you can attend my sessions, my special session, which are free sessions, from 5 to 6 p.m. Again, I teach quant over there, so your quant area will be quickly covered. We want to complete everything by end of August. That's our target. By end of August, you should be very clear with all the areas, right? So keep attending the other educator sessions. So for example, after my session, Shyam sir is going to teach you logical reasoning and data interpretation. In fact, prior to my session, different faculties are taking different topic, particularly verbal and general awareness. Also you can attend those sessions are happening, so keep attending that. So you are not online today at 2 p.m. Sumit, there was some technical problem. So as I mentioned, that there was a heavy rain, so the internet was fluctuating. We tried couple of times, so we are not among those who give up so easily. We tried couple of times, but then we realized, okay, it's better that we shift it tomorrow. That's fine. Okay, Mission 2020. Yes guys, yeah, and I'm soon coming up with my Instagram ID, so I'll share that Instagram ID with you. In fact, the Telegram discussion group is also on the cards, so we will find out more ways to interact with you. But yes, plus subscription will be slightly different, so go for that. That's also advisable. Now guys, we have understood what is permutation. In fact, we took plenty of examples of permutation. I don't know how much time are we left with. We're left with just 15 minutes. Okay, so now we need to understand combinations quickly, right? So combination, we understood it's grouping where order doesn't matter. So once again, if you want to select or make a group of 2 boys out of 3 boys, suppose there are 3 people and I want to form a group of 2 boys, or I want to make a committee of 2 boys. So I can make only this committee, AB, AC and BC. Now, if I make a committee of B and A, will it be different than this one? No, they are one and same. But if they are sitting on 2 chairs, AB and then BA, these are 2 different arrangements. So I'm sure you are now pretty clear about arrangement and combination, that is permutation and combination. Are you all clear? Show me a thumbs up quickly if you are clear about this. Yeah, great. So in general, if our objects, our objects can be selected out of n distinct objects. Please remember, again, the objects have to be different, only then this formula is applicable. So our objects can be selected out of n distinct objects in NCR ways. Okay, where NCR equal to n factorial upon n minus r factorial into r factorial. Yeah. So this is how you can use this formula, but we have the shortcut. So how to quickly calculate 10C2. So guys, what was 10P2? So 10P2 was 10 into 9. So what is 10C2? Just write 10 into 9 and then additionally put 2 factorial in the denominator. That's it. So for example, 8C3. So of course 8 into 7 into 6. And then additionally this 3 factorial in the denominator. Of course 3 factorial is nothing but 6. So 8C3 will be 56. 8 sevens are 56. So this is how you can do quick calculations. Right. Robin, I didn't get your question. So sir, just the question in comment. What does it mean, the question in comment? Can you please write the complete statement so that I can understand? Yeah, fine. Okay. So guys, combination, some important points. 0 factorial, it's 1. So same way NCN and NC0 both are equal to 1. Now what is NCN? So if there are 3 people ABC, And if I want to make a committee of 3 people, how many different committee can we make? Of course, one committee can be formed. But if there are 3 people A, B, C, and if you want to arrange them on 3 chairs, how many different ways can we do it? 3 factorial ways. So this will come out to be 6. So please remember, NCN equal to 1 and NPN equal to N factorial. So ये दोनों में confusion नहीं होना चाहिए, right? ये बहुत ही आसान सी चीज है, ये क्लियर कर लेना. सेम वे NC0 इज ऑल्सो 1. अगर 3 लोग है और मुझे किसी को सिलेक्ट नहीं करना है तो मैं कितने वेज में कर सकता हूं? मैं वो भी 1 वेज में कर सकता हूं. मैं सबको रिजेक्ट कर रहा हूं. सो देयर इज 1 वे ऑफ रिजेक्टिंग एवरीवन. प्लीज रिमेंबर दिस थिंग. Somewhere you will require to use that. So NCN and NC0 both are 1. Now NCR equal to NCN minus R. So अभी ये थोड़ा आपको समझना पड़ेगा कि अगर 5 लोग हैं A, B, C, D, E, और अगर मैं 3 लोगों की कमिटी बनाता हूं या मैं 2 लोगों की कमिटी बनाता हूं, द नंबर ऑफ कमिटीज विल बी सेम. आप खुद ही देख सकते हो कि अगर मैंने ए बी सी को सिलेक्ट किया, एक कमिटी बना ली, तो अपने आप डी और ई अलग हो गए, एक उनकी कमिटी बन गई. तो जितने अलग अलग वेज में ये मैं 3 लोगों को अलग कर सकता हूं, उतने ही अलग अलग वेज में मैं ये 2 लोगों को अलग कर पाऊंगा. तो 5C3 विल बी इक्वल टू 5C2. यस और नो? और इन जनरल यू कैन से NCR इज इक्वल टू NCN माइनस R. जैसे अगर आपको 16 में से 13 लोगों को सिलेक्ट करना है तो वो किसके बराबर होगा? 16 में से 3 लोगों को सिलेक्ट करने के बराबर होगा. यस तो अभी ये कैलकुलेट करना आसान हो गया है ना. हम क्या करेंगे? 16 को 3 स्टेप पीछे लिख देंगे एंड विल डिवाइड बाय 3 फैक्टोरियल. Okay, so that is a question which Robin has posted. I think I missed that question. Yeah, it's related to permutation. Robin, your question is something like this. There is an equilateral triangle. There are 2 chairs on 2 sides and there are 3 chairs on another side. All the chairs are different. So this 3 plus 2 plus 2, 7 people can be arranged in 7 factorial ways. Because there is an unequal side, so with reference to this side, these 2 sides are also different. You can also think it this way, that if A sits over here, A will think that okay, those 3 chair wala side is on my right, but when A sits over here, A will think that on my right there is 2 chair wala side. Are you getting, Robin? So this number of ways will be 7 factorial in this case. So just to answer your question. Okay, so guys, once again we are talking about combination. I am sure all of you have understood, especially this important point, that NCR equal to NCN minus R. Okay, fine. So I have already proved that point कि कैसे वो अलग हो जाता है. 3 लोगों के ग्रुप बनाओ या 2 लोगों के ग्रुप बनाओ, सेम ही हो जाएगा. Fine. So guys, now you need to beat the calculator. Everyone, tell me what is 8C3. Quickly type the answer in the chat box. Type the answer in the chat box. 8C3. Do not use paper and pen. 8C3. What is the answer? So what shall we think? 8 into 7 into 6, divide by 3 factorial. 3 factorial and 6 will get cancelled off. So it's 8 into 7. That is 56. Same way 6C4. Now instead of 6C4, can we say we need to calculate 6C2? That's easier. So 6 into 5 divide by 2 factorial, which is 2. So 6 into 5, 30 divided by 2, it's going to be 15. Can we do it this way? Everyone, are you all with me? Same way 12C11. So 12C11 has to be equal to 12C1. Correct? So now 12C1 is nothing but 12. 12 को एक step पीछे लिखो. That's it. It's 12. 14C12. So it's equal to 14C2. Now what is 14C2? It's 14 into 13 divide by 2 factorial. 2 cancel करो. 7 आ जाएगा. 13 sevens are 91. Can we do it this way, everyone? So quickly do it. Yeah, great. Fast. You know, to really be fast. NC2. Now how to simplify this NC2? So write n 2 steps backward, n into n minus 1 divide by 2 factorial. Further, if you want to simplify, so this can be n square minus n whole divided by 2. So this is how you had to write. And 10C0 is equal to 1. So these are certain points that you had to remember. Now tell me which of this is greater. So matlab which sign will you put, greater than or less than? Same way, which sign will be put, greater than or less than? Quickly tell me for first question and second question. Which signs will be put for the first question, greater than or less than? Everyone, tell me quickly. Type it in the comment chat box. Right. Please type it over there. Yup. So 10C3, is it greater than 6P4? What is 10C3, guys? It's 10 into 9 into 8 divided by 3 factorial. So this will come out to be 120. Isn't that? This is 120. And 6P4 is 6 into 5 into 4 into 3. So definitely this is more. This is 6 5s are 30, 4s are 120, 3s are 360. So we'll have to put less than sign. This is how it is. Yeah. Shubhankar has answered both of this question correctly. So first less than sign. Now 10C10 and 6P1. No, guys, even in second it will be less than sign. 10C10 is 1 and 6P1 is 6. So again less than sign. Please understand, 10C10 is 1 and 6P1 is 6. Yeah. So have you all understood this part? Let's go ahead with some questions once again. So in how many ways can you select 3 balls from 5 balls of different colors? Guys, this is straight away 5C3, very simple. But what about this one? In how many ways can you select 2 balls from 3 green and 2 red balls? You know, you must be playing that snooker. So in snooker, you have those identical red balls and so on and so forth. So here, the similar 3 identical green balls are there and 2 red balls are there. Let me just show it this way. There are 2 red balls and then there are 2 green balls. Let's use colors, guys. Let's make the world more interesting place. So we have 3 green balls. Now in how many ways can I do it, guys? Quickly tell me. Chalo. Right. So I need to pick 2 balls. Okay. In how many ways can I select these 2 balls? Quickly. Type your answer in the comment section, in the chat box. What are the total number of ways? Of course, we can't use that formula 5C2, incorrect. This will come out to be 10, but this is not correct answer. You can't use 3C2 also, incorrect. See, this NCR can be used only when N are different. Here, are these 3 balls different? No, so you can't use 3C2. Guys, the answer will be 3. There are just 3 ways. That's the answer. Why? So my 2 balls will be both green or red, or 1 green, 1 red. That's it. So these are the 3 ways. Have you understood, everyone? So please understand, when the objects are identical, you you can't apply that formula. That's a point that I wanted to make you understand. Now this is also very, very interesting question. Please tell me the answer for this. Tell me the answer for that question. Let's call question number 1 and question number 2. So we need to solve this question 1 right now. So in how many ways can you distribute 10 cards equally between 2 players? Wrong. Preposition. This is a preposition among or between 2 players A and B. Right? How many ways can we do it, guys? I want to divide 10 cards. Of course, cards are always different. Okay. So it will not be mentioned. By default, they are different. Like people are always different, but apples are always same. Animals, so if there are 10 elephants, they're always same. They are considered to be same. So how many ways can we distribute it between 2 players? Say Chintu and Mintu. And how many ways can we do it? So guys, what you'll do is you will select 5 cards out of 10 cards and you will give to Chintu, correct? Now, how many cards are you left with? 5 cards you are left with. So from those 5 cards, you will select 5. So of course, there is one way. That means the remaining 5 cards will be given to Mintu, right? So actually, this is going to be 1. So answer is 10C5. This are the total number of ways. Have you all understood this? Everyone, show me a thumbs up if you have understood this. Quickly. Yup. Okay. Great. So let's look at the second question. Now, what will be the answer for second question? In how many ways can you make 2 hips of 5 cards each from available 10 cards. Yeah. Now see, what is the difference? So these are two hips. Now guys, Chintu getting cards A, B, C, D, E and Mintu getting cards P, Q, R, S, T. Okay, and vice versa. Can I say these are two different ways? Right? But in terms of hips, you put ABCD over here or you put ABCD over here, it's one and same, because hips can't be differentiated, and that's why the number of ways will become half. If you want to understand, let's understand it this way. When there are two players, Chintu and Mintu, right, and suppose there are 4 cards P, Q, R, S. Suppose there are only 4 cards, because 10 cards will be too much. So PQ going with Chintu and RS going with Mintu is different from RS going with Chintu and PQ going with Mintu, right? But if nothing, the people are not mentioned, you are just putting in 2 hips. So now can I say PQ, RS or RS and PQ, it's one and same way of distributing cards. So this will be one and same. So total number of ways will become half, and the answer will be 10C5 divided by 2. Yes guys, everyone, have you understood this? Why am I dividing it by 2 in case of hips? Because hips are identical, but Chintu and Mintu are different. Look at the pose that Mintu is giving, right? It's very attitude wala pose, right guys? Okay. So yeah, hope you all have understood this basics of permutation and combination. I mean, once again, we are still at the basics. Tomorrow we are just going to discuss questions, all CAT questions. So we are going to take about 15 to 17 questions in about 50-55 minutes time, and that will clear everything for you. Okay, fine. In fact, not only that, we are also going to discuss the high level permutation and combination, like we are going to discuss partitioning, distribution, dearrangement. So these are some special cases of permutation. So we are even going to discuss that. So we are going to spend about 6 to 7 sessions on permutation combination probability. Okay, fine. So let's take few more questions. In how many ways can a committee of 5 members can be selected from 6 men and 5 women consisting of 3 men and 2 women? Very simple question. There are 6 men and you want to have 3 men out of them, so it can be done in 3 ways. There are 5 women and you want to select 2 women out of that, so it can be done in 5C2 ways, right? This is a simple question. But if I ask you this question, in how many ways can I form a committee of 5 members such that at least 1 woman is selected? At least 1 woman is selected. Now, can you tell me what will be the answer? Quickly do this calculation and type the answer in the chat box. Please do it. So guys, in that case, what I'll do is I'll find out the number of ways of forming a committee, which doesn't have any women, So I am making a committee of 5 members, all consisting of men. So of course, there are 6 such committees which I didn't want. So what I'll do is whatever ways I got over here, what is 6C3? It's 20. What is 5C2? It's 10. So it came out to be 200. From this 200, I'll subtract the 6 and the answer would have been 194, where at least 1 woman is selected, right? So this would have been the answer. Are you all clear up till now, guys? So we'll stop here for today, and tomorrow we are going to just practice plenty of questions. So there are a few more questions coming up, and then there will be slightly tougher questions. Okay, so that's it for today, guys. Please continue attending the sessions so that you can have uninterrupted preparation. Tomorrow in the afternoon, I'm going to teach you algebra basics. Then in the evening, 5 o'clock on Unacademy platform, I'm going to teach you the number system. We are going to continue with number system in case if you have missed that session. And in the evening, 9 p.m. once again with the permutation and combination. Right. So before we wind up, guys, let me quickly tell you something about this Plus subscription. So this is what you get. You get test series, you get leaderboard, regular leaderboard, and personal interaction, and you can attend my courses. And this is how you can go for Plus subscription. In case if you're not aware, you need to download this Unacademy learning app, and once you have installed that, then you select Plus. You also select your goal as CAT, and then you click on subscription plan. So you'll see various plans. You choose your plan, and then you apply my referral code in step number 7, SHAH10. So just note down this referral code and you will get this discount. In fact, these are my timings, so you can attend my sessions regularly, right? And yeah, these are some of our other courses. So in case your friends or family members are looking for that, please introduce Unacademy to them as well, right? And yes, you can at least download the Unacademy app so that you can attend my special sessions even if you are not going for subscription. Do not forget to share our channel on your Facebook and Instagram page. Our mission is to make it India's #1 CAT prep channel, so please support us in that, and do not forget to press the bell icon for yourself. Yeah, please quickly subscribe to Telegram channel as well. And yes, let's crack the entrance exams together, guys. That's it for today. See you. Good night.